today's session, and I hope everyone can able to see my screen. So today, as I said, we are going to learn about how a select statement is going to process in the database. But for that, well before we need to understand about the phases of SQL execution. So if you have been issued with a select query or any other SQL statement, how exactly it is going to work on what are all the phases that are involved. So we are going to learn about that first. So as you can see on the screen, phases of SQL execution are of totally we have three phases in place. The first one being parsing, and the second one being execution, and the third one is fetching. And each and every phase is again having subphases. Like parsing is having syntax checking, then semantic checking, and dividing the statement into literals as the subphases. And execution is also having convert to ASCII format, then compilation and execution. And fetching is also having either a physical read or logical read. So coming to parsing, so the first one is syntax checking, and I don't require to explain this because you people are very well aware what is meant by syntax checking. So right from the language of C till whatever the latest language that we have or any thing that we are going to manipulate, this syntax checking is a mandatory one. So that is what will happen when you write a select statement, whether that is followed the correct syntax or not will be checked in this parsing phase. And the next one we have is semantic checking. So semantic checking is nothing but checking for the privileges and confirming whether the user is having proper privileges to access the table or not. For example, let's say I connected as a Spot user and I issued select star from EMP. Definitely it is going to retrieve me the rows whatever is there in the EMP table. But if I connect as a user Pavan and if I issue select star from EMP, that might not work because EMP table is belonging to Spot user. So when I connect as a Pavan user and if I am trying to say select star from EMP, that means I want to access the data of EMP table which is belonging to Spot user. So for that, first of all, the user Pavan should have permissions on the EMP table. So if that permissions are there, then yes, Oracle will allow you or will give you the data, or if not, Oracle will straight away says you don't have sufficient privileges in order to access the table. So this we call it as authorization of the user. So authorization of the user is nothing but checking for the proper privileges, and that checking for proper privileges will happen in semantic checking phase, and this will be done with the help of base tables. So we have been talking about base tables yesterday. So with the help of those base tables, semantic checking, that is checking for the privileges, will takes place. And the third phase that we have is dividing the statement into literals. For example, as you can see in the PowerPoint slide itself, if you have been provided with a select statement like select star from EMP, it is going to divide the clauses like select will be separated, star will be separated, from will be separated, and EMP will be separated. Even the semicolon also will be separated. So each and every word or each and every symbol that you are using in the statement, it will be divided into separate components, and we call that as dividing the statement into literals. So these three are the subphases that we have in parsing. And then we have execution phase, and in execution the first phase is converting the statement into ASCII format. I hope you people know what is meant by ASCII. So the abbreviation stands for American Standards Code for Information Interchange. So if you want to interchange the information from numbers to characters or characters to numbers, basically this ASCII code is going to help you. Like basically ASCII is a table in which every character will have a number assigned, or every number will have a character assigned, and even the symbols like the star mark, or I mean to say asterisk or semicolon or equals to, all these symbols also will be having some numbers assigned. So what happens in this converting to ASCII format is, whatever the statement that was divided into literals in the previous phase, that is in parsing, so now that statement will be converted into number format or numeric format. So even though you have written in an English like statement, so select star from EMP, this entire select star from EMP statement will be converted into ASCII format, that is numeric format. And once that conversion has been done, once again compilation will be taken place, and after compilation that will be executed. So the numeric form of SQL statement will be executed, and once the statement got executed, then Oracle will understand what exactly the user is asking for, and then it is going to for the next phase, that is fetching. So while doing the fetching of the data, again it is going to follow the operating system process. First it is going to check whether the data is available in the instance or not, and if the data is available in the instance itself, then it is going to give you the data, and this we call it as logical read. So logical read means you are going to pick up the data from the instance itself. And the other one we have is physical read. That means when Oracle is checking for the data in the instance and it couldn't able to find the data, then it is going to definitely copy that from the database, and we call that as a physical read. So physical read is nothing but IO, and the logical read is not an IO. So when it comes to database functionality, already we understood yesterday the point that more number of IOs will lead to the less performance of the database. So if number of physical reads are more, it will degrade the database performance. So always the logical read count should be more than the physical read count. So these are the three phases that we have under under SQL execution. Any queries over here before we proceed for the next slide? Okay, so let us move to the next slide, and yeah, I will come to, still we have not discussed about that. I will come to that one. So now let us go and see how exactly the select statement is going to work in the database, or how it is going to process in the database. Now what happens here is, yesterday we understood about what is user process and what is server process, and then we talked about little bit about PGA, so all these things. And we also understood a point that once the connection has been established, there will be no concept of listener in place. And that is the reason in this diagram also I am assuming that user process has already established a connection, and that is why you have server process created, and PGA is also the memory, so which was allocated to server process, and you don't have listener. Now once the connection has been established, let's say user process has issued the statement select star from EMP. Now what happens after user process issues this statement? So after user process issues this statement, the server process which is residing over here, it is going to receive that statement. So whatever the statement that was issued by user process, it will be received by server process. and after receiving, server process will send this statement to library cache. So there is a component called library cache under a component called shared pool. So server process, what it will do is, whatever the statement that was received from the user process, it is going to send that to the library cache. And in library cache, whatever the parsing phase that we talked about, like syntax checking, then semantic checking, and dividing the statement into literals. So all these three steps will be performed in the library cache. That means entire parsing is going to take place in library cache. And once the parsing phase has been done, then before going for execution, there will be a new component in place. So that component name we are going to call it as optimizer, and this component is going to reside in library cache itself. So here itself we will be having optimizer, and this component task is to generate the plans for the statement. So what exactly mean by this optimizer, and why exactly it is going to generate different plans, or first of all what is this plan means. Now plan is something like a map kind of thing. So here you have let's say a source and a destination. Generally in map, even I hope everybody might have observed Google Maps also. There you can provide your source and destination locations, and the Google Map will give you the path in which you need to travel. So like the same way, if a select statement was hitting the database, how it need to retrieve the data will be decided by a plan, and that plan will be generated by this optimizer. Now the name itself is telling you optimization. So the name is optimizer, and the task it is going to do is optimization. Now what it is going to optimize? Now normally when we write this, when we keep on issuing the SQL statements, definitely every SQL statement will consume some memory as well as the CPU power. So optimizer's task is to reduce the memory consumption as much as possible, and also the CPU consumption as much as possible, but you need to give the desired results in the specific time frame. So that is what basically it is going to happen in the optimization path. So what happens after server process sends the statement to library cache? As I said, parsing will take place, and once parsing got completed, then optimizer is going to generate the best execution plan. And as I said, the execution plan is nothing but a map kind of thing, and which will show you how you need to travel. So in the same way, here it is going to tell to SQL statement how to reach the destination. So in for example, if you take select star from EMP, in that statement the destination is EMP table. So this optimizer is going to tell to that statement how you need to reach that EMP table, how you can fastly reach the EMP table, and how fastly you can retrieve the data. So that is what basically optimizer is going to do in library cache. So any queries over here before we proceed for other steps? So if you have mic, please turn on that and ask a question rather than doing chatting. Okay, so once parsing got completed, Then as I said, optimizer will be generating the plan, and now server process, what it will do is, by taking the plan which was generated in library cache, so server process is going to come down to PGA. So we have a memory component called PGA. So yesterday we learned about 2-3 points regarding PGA. Like the first point is PGA stands for Private Global Area or Program Global Area. And the second point we understood is PGA is the name given for the memory that was allocated to server process. So what happens here is, server process, once the optimizer generates the best plan, by taking that best plan, it will come down to PGA, and in PGA, whatever the phase called execution will take place. So if parsing is going to take place in library cache, the execution is going to take place in PGA. So once execution has taken place, then server process will start searching for the data in the instance. So that is what I said. In fetching, what happens is, first Oracle will try to do logical read. Logical read means checking for the data in the instance itself. And how that will be performed is, server process will check for the data in the LRU list. So there is a component called database buffer cache. So this component has basically been divided into two categories. One is write list and another one is LRU list. And the server process is going to start looking out for the data in the LRU list. And if the data is found in the LRU list, that will be given directly to the user process. And if the data was not found in the LRU list, then server process is going to server process is going to travel to data files or database, and it is going to copy that data into LRU list, and then the data what was copied into LRU list will be given to the user process. So just like how operating system is going to work, or what we have seen yesterday, similar way, first server process will check for the data in the LRU list. If the data is not there, server process will go to database, and from database it is going to copy the data to LRU list once again, and from that LRU list the data will be given to the user process. And this is how the select statement is going to work, and it is going to give you the data. So any queries here?
What is LRU list? What is LRU? It stands for?
Sorry, Sanjit, can you speak a bit louder, please?
What is LRU?
Yeah, LRU stands for least recently used list. Okay, so if you remember yesterday we were talking about one point, that how the data in the instance will be managed, and we understood that that is used or that is being done based on algorithm that is being done. So basically this least recently used list is going to follow the LRU algorithm. So once again I am going through the steps. So the first step is, user process will be issuing the statement and server process will receive the statement. Then server process will send the statement to library cache, and here parsing will take place, and after parsing optimizer is going to generate the best execution plan, and by taking that best execution plan, server process is going to come down to PGA, and in PGA we will be having execution taking place, and then server process will start looking for the data in the LRU list. So it will scan the entire LRU list for the data, and if the data is readily available, then it will be given to the user process, or otherwise server process is going to database, and it is going to pick up the data and it is going to copy into LRU list, and after placing into LRU list, the data will be given to the user process. So this is how the data will, or the select statement will work in the database. Now here we need to understand a few points. Like the first point is, whatever the data that was being copied from the database to the LRU list, so that will be done in the form of blocks. Normally, the data will be stored in the form of rows and columns or inside the tables, but that is as per the table level or as per the data level. But what usually happens in Oracle database is the data will be stored in the form of a block. So for example, on the left hand side I am drawing the diagram. So something like a box that you can see here. So if you assume this is a block, and your data or your rows will be stored like this. So whatever the rows that you have, those rows will be stored inside a block like this. And the standard block size that Oracle maintains is 8 KB, and if your table size is less than 8 KB, then definitely for one table there will be one block. But if your table size is more than 8 KB, then you may require 2 or 3 tables. Suppose your table size is somewhere around 30 KB. So, but the standard block size is 8 KB. So in such case, what happens is one table will be splitted across multiple blocks like this. So that means the rows of the table will be spread across multiple blocks. So this is what basically Oracle is going to follow. So inside the database, how the data will be stored is in the form of blocks. So whatever the rows that we are talking about, which will be there inside the table, those rows will be residing inside these particular blocks. And when server process is reading the data from the database to the LRU list, then frankly in the LRU list it is going to copy that entire block. So it is going to copy the block like this, and from there the data will be given to the, so this block will be given to the user process. So this is one point that we need to understand. So are there any questions over here, or everybody understood this point first of all? Okay. So now generally in the database, what happens is there will be multiple users connecting, right? That means there will be several user processes and there will be several server processes. Let's suppose you have 100 users connected. So when 100 users got connected, there will be 100 user processes, and for each and every user process there will be a server process. That means even the server process count is also 100. So that means for every user process there will be a dedicated server process. Now let's assume all these server processes are copying the blocks into the LRU list. Let's say like this. So all the server processes are keep on copying different blocks here. Then what happens is at some moment of time your LRU list will become full, isn't it? So when 100 select statements were issued and all the 100 statements are trying to use the same LRU list, then what happens? Your entire LRU list will become full. Now when the entire LRU list become full, what Oracle will do is, whatever the blocks that are available at the bottom portion, so you can see over here, so whatever the blocks that are available at the bottom portion, which I am drawing in blue color, so these blocks will be removed from the instance, or these blocks will be flushed out from the instance. So when these blocks were flushed out from the instance, the above blocks will will be moved into the below portion. So it's just like a queue. So whoever is going to enter into first, that data will be leaving at the first time. So I'm just explaining you in a different way. Suppose server process copied the data from the top portion, like from here. Then what happens is your data or your block will gradually move down to LRU, the bottom portion of the LRU list, and finally from there it will be flushed out from the memory. So this is how the data will be traveled. Whenever a select statement was issued, or whenever you want some data to be there and all. So this is applicable for any select statement. So any select statement, or any statement which is trying to retrieve the data. So the data should be copied at the top portion of the buffer cache, or sorry, LRU list, and the data should leave at the end portion of the LRU list. And because this is going to happen through LRU algorithm. So whatever the data that is coming to bottom, it means that the data is least recently used, and whatever the data that is very older, least recently used data is nothing but older data. So whatever the older data you have, that will be flushed out from the LRU list. So that means data basically enters from the top portion of LRU list and will leave at the bottom portion of the LRU list. So it's basically working in a queue mechanism. So is this point clear with everyone? Okay. So that is how the select statement is going to work in our database. And now usually, as I said, server process, what it is going to do is, in searching phase, it is going to start searching with the bottom portion. So it will start searching at the bottom portion, and it will try to reach the top portion. Now there may be a question asking, like, why server process is starting only from the bottom portion? Why can't it start searching from the top portion? So as I said, the reason is the data will be keep on removing from the bottom portion. So if the server process starts searching from the upper portion, and there is some data that was ready to leave from the bottom portion, then what happens is, by the time server process reaches the bottom portion, or by the time server process travels like this and reaches the bottom portion, this data might have already been flushed to the flushed out of memory. Then what server process need to do is, again it need to read from the database. So instead of that, what Oracle has designed its architecture is, let server process start from the bottom, and suppose some data is there which is about to flush from the memory, and this is the data what server process is looking for, then directly it can give the data to the user process. So to give benefit for that, basically the concept was designed like server process will start searching at the bottom portion but not at the top portion. So that is one more point that we have in. Now let us go and talk few more points regarding base tables. And have you guys received the soft copy of this class notes? Oh, you didn't receive it. Oh my God. So, just a minute. Okay. So I have just intimated Vishnu. So might be you will be receiving it by tonight or tomorrow morning. So fine. I hope you people can see my screen. So let us talk about few points regarding base tables. So the first point says base tables will store the information that is helpful for the database functionality, and this information we are going to call also as dictionary information. And base tables usually will be in the form of some name suffixed with a dollar sign. So usually the name of the base tables will be something like a name which ends with a dollar sign. So for example, if you see some base table like user dollar, then you need to understand that it is a base table because dollar sign is there at the end of the name. And it is going to reside in the system table space. So we don't know what exactly is my system table space. So we will be learning it further. So at that time you will understand that point. And the next point says the information inside the base tables will be in cryptic format. That means it will not be in human readable format. So because of this, we can access the base table. That means you can do select star from base table name. But because the information is in cryptic and the output it is going to show you is also cryptic, you could not able to actually view the content of the base table. So that is what basically the thing is. So even though you can access the base table, the security mechanism that was implemented is the information will not be in the information will not be in human readable format. And the fourth point says if you try to modify base tables, like if you perform some DML or DDL operations on base tables, that may lead to the database corruption, and only the background process will be having the authority to modify them. So whatever the background process you are seeing on the screen, like SMON, then PMON, then DBWR, LGWR, so all these background process are basically having the authority to update the base tables. And as a DBA, we should not do that directly. And the last point, fifth point, is quite important. Base tables will be created at the time of database creation using a script called sql.bsq. So how the base tables will be created is, while if you create the database, Oracle is going to invoke the script sql.bsq, and this script is going to create the base tables for us. So with this, as we already understood that base tables information will be in cryptic format, but let's say you want to collect some information from the base tables, and it is in non-human readable format. So in that case, it will be a problem. Suppose you want to know how many number of users are there in the database, so that information will be there in the base table, and if that base table is if you could not able to retrieve the data from the base table, then it would be a problem. So that's the reason what Oracle has done is, on top of these base tables we can create, or already there will be some views created by Oracle database. And there are basically two types of views, as you can see on the screen. The first category we call it as data dictionary views, which is nothing but, or which are going to store the permanent information of the database. And there is a naming convention also. So the naming convention is like DBA underscore, then the table or the view name. So this is how we will be having the first category, and the second category of views are dynamic performance views. And the format of these views will be like a $v some name. So that means the name will be prefixed with $v, and these views are going to provide the ongoing actions or the current actions in the database. So to understand, so data dictionary views are going to give you permanent information, and whereas dynamic performance views are going to give you the ongoing actions. Now to understand this, let me give you an example. Suppose your senior management or your client asked for the information like, they asked basically, let us say, two questions. Question number one, we need to identify totally how many users are there in the database. That is question number one. And question number two, we need to identify how many users connected right now to the database. So question number one is totally how many number of users are there in the database, and question number two, how many users connected at this moment. Now first of all, do you guys agree whether these two queries or two questions are different or not? So is these two questions same or different? So the first question is how many number of users are there in the database, and question number two, how many users connected at this moment. Yes, definitely these two questions are different. Okay, so for example, in your Facebook, you may have 100 friends added out, but in your chat you may have only 30 or 40 friends, on online. So this is the difference. Total number of friends you have is permanent information, and how many of your friends are online, that is ongoing action. Because the this moment one friend may be online, and in the next moment that friend may be offline. So that information is going to vary a lot. So in the same way, data dictionary views are going to give you the permanent information. That means how many number of users are there in the database, you can find out that from data dictionary views, and how many connected at this moment you can identify from dynamic performance views. And both of the views, so both the category of views will be created after the database creation. So here you need to understand one more difference. Base tables will be created during database creation, but these views will be created after database creation. So once your database has been created, then we need to execute a script called catalog.sql, and by executing that script, we will be able to create these views, both the type of views. And apart from this, we need to execute one more script also, that is catproc.sql, and it will create some packages and procedures in the database, and as a DBA, some of the situations we will be using these packages and procedures. So wherever we come across those things, I will be explaining you about them. So don't worry at this moment of time. And The fourth point is going to talk about the same. Catalog.sql and catproc.sql script should be done after the database creation, and if the database is created manually. So database creation, how you can do is using two ways. One is using a manual method, like you need to follow different steps and you need to achieve it. And the second one is you need to just make use of a tool called DBCA, so which stands for Database Configuration Assistant. So you can make use of this tool and then you can create your database. So when you create your database using DBCA, you don't require to run these two scripts which are mentioned in point numbers 2 and 3. That is catalog.sql and catproc.sql. But when you create your database manually, then yes, definitely you need to create or you need to execute both of the scripts. So anyways, we will be seeing that in manual database creation. And the location of these scripts will be like Oracle underscore home slash rdvms slash admin. And what is meant by Oracle underscore home here? Oracle underscore home is nothing but the location where you installed Oracle software. So that is what basically Oracle home means. Wherever you install Oracle software, and that location we are going to call it as Oracle home. Suppose if I created a database or if I configured Oracle under a mount point called U01, then we can call U01 as a Oracle home. So that is what we have few points regarding base tables and the views on the base tables. So any queries over here? So that is how we have base tables and different views in place. Then we will be having those things. So if you look at the diagram, what you can see on the screen right now, your instance has been divided into two components. One is memory structures and the other one is background process. And your database has been divided into two components. One is logical structures and the other one is physical structures. So memory structures in our architecture is nothing but all these components like shared pool, then database buffer cache, then log buffer cache. So all these are memory components, and all the background process that you are seeing here, smon, pmon, dvwr, etc. are the background process. And when it comes to database, whatever the files you are seeing here, the data files, redo log files, control files, so all these files will be considered as physical structures. But apart from physical structures, database also contains logical structures. So to understand the next topic, we need to first of all understood about what is logical structure and why it will take place, all those things. So let us go and have that information or have a look at that. So there are totally 4 types of logical structures in place, and when I say logical, definitely this cannot be visible to the eye. So logical structures will be internally managed and maintained by Oracle database. So there are totally 4 logical structures, starting with the first one, that is table space, and second one is segments, third one is extents, and the fourth one is data blocks. So to understand about these logical structures, let us go and look from bottom to top. So let's not travel from top to bottom. Let us go in a reverse way. So just now we discussed about what is Oracle block and all. And as I said, Oracle block is nothing but a storage area where you are going to store the number of rows inside a table. And also I said that we have a standard block size that is 8 KB. So those are the few points regarding data block. And on top of this data block, you have a logical structure called extents. So what exactly mean by extents is, as the first definition or the first line says there, a group of Oracle data blocks is called as extents. So suppose you combine some 50 blocks or you combine some 100 blocks. So altogether those blocks we are going to call it as an extent. And not only that, extent is also having one more definition, and that says it is the smallest unit of memory that is allocated to a table. So when you create a table, Oracle will allocate some memory in order to store the data, like 1 MB or 5 MB or 10 MB, like that. So that size we are going to call it as extent. And if you look at the diagram here, you can be able to understand better. So you can see the last row is nothing but multiple blocks. So some of the blocks combined together, we call it as extent number 1, and some other blocks we are going to combine them and we are going to call it as extent number 2. So that is how the relationship between the extent and the Oracle data block is. And on top of extents, you will be having one more component called segments, and you can read the definition there. A segment is nothing but an object which is going to occupy the space in the database. And normally inside the database there are two objects which will occupy the space. One is table and the other one is index. So apart from these, no other objects will be storing the data or will occupy the space. So that is the reason we call them as segments. And we have one more definition for the segment, which says it is a group of extents. And again, if you look at the diagram over here, segments, multiple extents like extent number 1 and extent number 2, it is going to combine together into a single segment. So this is how it is going to happen. And finally, we have a concept called table space, and there are some definitions regarding table space. The first one is it is a alias name to a group of data files. So if you have 100 data files, instead of calling and you want to do some activity, so instead of calling 100 data files like data file 1, 2, 3, etc., what basically we can do is multiple files we can combine together and we can create a table space. And there is another definition, so which says it is a place to store the tables. Definitely a table space is the one which is going to help you in order to create the tables or in order to hold the tables. And last definition says it is a group of segments. So again, if you look at the diagram here I don't have multiple segments, but if at all I have multiple segments, then it can be combinedly forming a table space. And this is how we have 4 logical structures: the table space and segments, extents, and Oracle data blocks. So are there any queries? Okay, so that is how we have the logical structures in place. Oracle data blocks are the actual location where our rows are going to be stored, and a group of blocks we are going to call it as extent, and a group of extents we are going to call it as a segment, and a group of segments we are going to call it as table space. And a table space will be based on a component called data files. So if you look at the architecture diagram, then you can see here there is a component called data files. So based on this component only, you can create table spaces. And we have some mandatory table spaces. So when you create a database, automatically some table spaces will be created. So let us go and see what are those mandatory table spaces and what happens if you don't have them. So the first table space name that we have is system, and this this table space is going to store all the base tables, like whatever the base tables we discussed, for example about table information or about user information, etc. So all these base tables will be stored in this particular table space, that is system table space. And apart from system, we have one more table space called sysocs. And this sysocs table space was actually introduced in 10G. Earlier to 10G it was not there. And what exactly is the definition of sysocs table space says is, it is an extension to the system table space, and that means this sysocs table space is also going to store some base tables data, or the the data definition data, and this is to reduce the burden on the system table space. So because system table space will be already busy with the different activities, so to reduce just the burden of it, Oracle has introduced sysocs from 10G onwards. And then we have temp table space. So whenever query was issued with the order by or any other clause, then in such case you can make use of this temp table space. And finally, undo table space. So whenever the transaction completed and either you don't know whether it is a committed one or a rollback, so in such cases you can make use of undo table space. So what exactly undo is going to store is before images or before values. Instead of calling it as before values, it is better to call it as before images. So these before images will be stored in undo table space, and why we require is, in case if in future user is asking to do a rollback of the transaction, and if the transaction has not yet been committed, then yes, we can go and change, or we can go and make use of this undo table space. So these are the 4 mandatory table spaces that we have from 10G onwards. And as I said, out of these 4, only the sysocs got introduced newly, but earlier 3 table spaces were there from 8A also. So any queries? So that is what I want to explain today. We need to look at how a DML statement will process in the database, like how an update statement will work in the database, or how an insert statement or delete statement will work in the database. So we will see that tomorrow. The reason is because you have not received the class notes, so I just don't want to jump into more topics, because I feel at least in architecture you people need to take some time in order to understand what's going on in the Oracle database, because this is going to help us a lot whenever we do performance tuning and all. So that's the reason. So I'm just holding the class today at this moment, and we can discuss if you have any queries and all. Yeah, we will come to those things. Indexes also will be stored in table space, but that will be stored in non-mandatory table spaces. So whatever we saw is mandatory table space. The tables or the indexes, etc., will be stored in non-mandatory table spaces. So what we usually do is, after creating the database, or along with database creation, you will get these 4 table spaces, and after we create database, we will be creating some table spaces, or we will create our own table spaces, more clearly to say. So in those table spaces, we will be putting this tables, indexes and all. So if you have any other queries, anyone, just you can type in the chat window, or you can ask me directly also. Yeah, tomorrow it would be same time, or you want earlier, so it's your call. But it cannot be before 7 o'clock because I have office tomorrow, and it will be completed by 7 o'clock. So after, if you want to start at 7:30 and all, I am fine with that. So depends on every other people also. Yeah, even fine. I don't have any issues. So let us stick to the same time. Okay. So how many is okay? How many of you people are okay to have at 7:30? So let's take a voting, and then we will decide it. Okay. Okay. It seems most of the people are opting for the same time. So yes, then stick to the same time. Tomorrow also it will be 8:30. So then we will, tomorrow we will discuss about Sunday. Let's not hurry up today itself. So tomorrow after the class we will decide what time we should go for Sunday. So we will decide that later. So any queries that you have? Yes, Sanjay, I didn't got time to go through your CV. I will be looking into it now after the class, and I will reply you. And hope you people are getting the videos. So anybody verified whether you can able to access all the videos or not? Because daily I am uploading it, but even I need to get a confirmation from your side also that they are you can able to download them. So can anyone confirm me on that? Okay, if no one has checked out, please check out today. Yeah, like one thing, Sanjay, some of the rack videos Vishnu is working on them, so he is uploading that to a site. We have a site called dbatalent.com. So to that site, he is going to upload the rack videos, like the installation of rack or other administration things. So he is basically working on that. So might be soon, in a week time or so, you will be having those videos. Yeah, I'm just typing in the chat window. The site name is dbatalent.com. So this is the site name. So not only rack videos, videos related to DBA, videos related to apps DBA. So all those things will be uploaded to this site. Okay, fine. Then let us meet tomorrow at the same time, and we will look into how ADML will process and all other things. So thank you everyone for joining the session, and have a nice time till tomorrow.